Hey guys, welcome to the second math video. Today we're talking about scale diagrams and enlargements. Remember, an enlargement is a diagram that's larger than the original object. Why might someone create a diagram that's larger than the original object? Here's a few reasons. First of all, to be able to see the object like an onion cell, to see the object in greater detail like a diagram of an insect, or to see more texture like on a cereal box. Many cereal boxes say something like enlarged to show texture. So that way you can see the cereal better than if it was actual size. What are some ways to create an enlarged object? Well, one way is to zoom in with the camera. You can look through a microscope. That'll create a bigger image of what's on the slide. Or you can use a photocopier to create a larger copy or to zoom in on what you have on the original piece of paper. A term you may have not heard before is called scale factor. Scale factor tells us how many times bigger or smaller our diagram is compared to the original object. So today we're just talking about things that are bigger. So when it comes to enlargements, the scale factor will always be greater than 1. Whether it be 2, 3, or 100, it'll always be bigger than 1 when the diagram is bigger than the original object. So for example, a scale factor of 4 means that the diagram is 4 times larger than the original object, like the picture of the ant below. So here we have the actual ant, which is 1 centimeter, and the diagram of the ant, which is 4 centimeters, meaning that this ant is 4 times bigger, so the scale factor to create this diagram is 4. If we're given an object and then also a scale diagram of that object, we can calculate the scale factor. For example, look at the diagrams of the F below, or the letter F's below, and make note of how long each segment is. You have a blank copy in your notes. Write down the lengths of each segment. Recall that the term corresponding refers to something that is similar on both the diagram and the original object. So on the letter F's above, the 2 centimeter vertical line on the original and the 5 centimeter vertical line are called corresponding lengths. These ones with the green here are corresponding because they're the same part of the F on both the original and the diagram. So here's the F's again. How do we determine the scale factor of this diagram here? It's bigger. How many times bigger is it? That's what we want to figure out. That's the scale factor. We use the following fraction. So you take a length on the enlarged diagram, that's on top, and then a length on the original object on the bottom. So the lengths that you use in this fraction must be corresponding with each other. So you couldn't use 5 from here and 1 from here. It has to be kind of the same side of the F in order to compare them. So remember that fractions mean divide, so we'll be dividing this fraction to get a number. Let's start with the vertical lines with the green line that we've looked at before. The length on the diagram is 5 centimeters, the one going up and down, and the length on the original is 2 centimeters. So we put that into a fraction. Length on the diagram is 5, length on the original is 2. We divide, we get 2.5. This is the scale factor. So that means that the diagram is 2.5 times bigger than the original object. So here they are again. And now let's take a look at, that was the vertical. Now let's take a look at the horizontal segments. So this one here, 2.5, and this one here, 1. So we put it to the same fraction. Length on the enlarged diagram is 2.5. Length on the original object is 1. Divide, we get again 2.5. Same scale factor, that's good. So since every pair of corresponding lengths has the same scale factor, 2.5, we say that the corresponding lengths are proportional, or this diagram here is proportional to the original. Where have you heard the word proportion before? Well, here's one example. A child that has not grown into his body may have a head that seems too big for his body. So people would say then his head seems to be out of proportion compared to his body. Can you think of any other examples where you've seen the word proportion? Pause the video now and write them down. Good, we'll talk about these in class tomorrow. So the scale factor must be the same for all pairs of corresponding lengths in order for the enlargement to be considered a scale diagram. So for example, here's the original F, the same thing. This length is 2.5 times bigger, it's 5 centimeters, but this one hasn't changed. So this enlargement is not a scale diagram because the vertical and horizontal segments were not enlarged by the same scale. So we would say that the enlarged F is not proportional to the original F, right? These were not enlarged in the same way that this one was. So it's not proportional, it's not a scale diagram. Here's a couple of examples. So the first one says, determine the scale factor of the enlarged diagram below. So remember, we always, when we come into our fraction, we always go diagram on top, and then the actual or original length on the bottom. So in this one here, the diagram length is 6.75 centimeters. And the actual spider is 1.5 centimeters. So remember, we have to divide these, and what do we get? Let's punch it in here. We go 6.75 divided by 1.5. We get 4.5. So that means that the diagram of the spider is 4.5 times bigger than the actual spider. That's also the scale factor. This one here, it says this drawing of a mosquito was printed in a newspaper about West Nile virus. The actual length of the mosquito was 12 millimeters. So remember, we go diagram over actual, and we know that the actual length is 12 millimeters. We want to determine the scale factor, or how many times bigger the diagram is. So we need to measure the length of this mosquito here. So you line up your ruler, and we get all the way out here to 4.5 centimeters, which is the same thing as 45 millimeters. Okay, so then we divide. We have 45 on the diagram, 12 on the actual. We go 45 divided by 12 equals 3.75. Which means that the diagram is 3.75 times bigger than the actual mosquito, and also the scale factor is 3.75. One more example here. There's a photo of a longhouse, and the dimensions of this photo are 9 centimeters. It's 9 centimeters long by 6 centimeters high. The photo is to be enlarged by a scale factor of 7 over 2. 7 over 2, that's a fraction. It's a lot easier if we turn that into a decimal. So we want to divide 7 divided by 2, and we get 3.5. So we want to make a photo that's 3.5 times larger. So that means we need to multiply both the length and the height by 3.5 in order to get the dimensions of the new enlarged photo. So let's calculate this. We go 6 times 3.5, we get 21. So that means that the new height is 21 centimeters. And then the new length down here, we go 9 times 3.5, and we get 31.5 centimeters. So these are the dimensions of the new photo once we enlarge it. So we can use a scale factor to determine new lengths, or we can use lengths on the diagram and the actual mosquito or whatever it is to figure out the scale factor. So don't forget to answer the questions on the Google form or on the bottom of the note sheet. Thanks a lot. See you tomorrow.